Hey guys, welcome back to another episode of Simuleos. Today's going to be an absolutely fantastic day, I'm pretty sure. Let me just go ahead and put on this blue shirt. I know I'm wearing a shirt, obviously, but I don't know, I like wearing collared shirts. So anyway, we will see how far we get today. I'm fairly certain, let me check the camera, and also after checking the camera, move this out of the way. Hopefully it's not going to freeze the camera like it did yesterday. I have no idea how that happened, by the way. Yesterday I just opened up the blinds and for some reason the camera froze. Technology. How does it work? Okay, so today guys, we're going to continue working on what we were working on yesterday. We're going to get out that lens texture, and then we're going to start throwing some random rays into the lens, hopefully making things look cool, and we'll see what happens. Lots of things we could do. Alright, let's get started. So, first things first, let's open up Zernal. Let's talk just like 2 minutes about what it is we're actually planning to do. So, here is the idea. We have a lens, and the lens is a circle. Now, we could use any type of shape. It doesn't have to be a circle. However, for the purposes of this simulation, we've been using circles the whole time. It's easy to create functions that are functions of R, and we can do some crazy stuff with that, so that's kind of what we're going with here. Here's our circle. There we go. And here's light going into the circle. That's more curvy than I thought it would be. So here's light going into the circle. Let's do it with this guy first. Okay. The light goes in here, and it does some sort of crazy thing. In the case of an invisible lens, it does something like this, pops out on the other side, and then it comes out here. Okay, so we have a single ray. What we want to do, first of all, we want to make it so the interior of the lens right in here is itself a... You know, that was supposed to be a square. That was definitely supposed to be a square, and I thought it was a circle. I mean, come on. That doesn't even look like a circle. Okay, Control Z, let's try it again. Channeling our squareness. Isn't very hard on this channel, we have lots of squares here. So we're going to take this, we're going to turn it into a texture. And then all we're going to do from there is after turning it into a texture, we're going to plot out the refractive index at each point. And this should make it so it's more intuitive as to what's happening on the inside of the lens. Why is the light rotating? Why is it turning? It's always turning towards areas of high refractive index. And that's pretty cool. I think that's going to help us out significantly in terms of explaining how and why the light bends. Okay, so the next thing we need to do is send thousands, that was yawn guys, sorry about that, of rays. This should give us a pretty cool looking plot that shows where the light is kind of congregating on the inside of the lens, what is being focused on and what's not. And then we want one ray, scan. And this is basically going to be this ray, it's going to be moved down, and then it's going to be moved back up. And we're just going to kind of visualize that movement. So we have 3 different visualizations I want to run, and honestly, if we don't get it done today, we'll get it done tomorrow. There isn't really that much left to do here. Just a matter of getting it coded up and shipped out. As far as the next simulation is concerned, I've been looking up things on conformal mapping, I've been looking up things on FFT stuff, lots of things. Thanks, Addison. Here, let me just do this for now. That's all I wrote. Thousands of rays, 1 ray, scan. I need to find a better solution. I mean, I know where my pictures are. They're like right here. So just not do anything in that region. Anyway, there's really not much left for us to do after that. So this simulation is pretty much done once we get that done. And then it's just a matter of trying a whole bunch of cool lenses out and seeing what we get. Hey, I care. So it's kind of like redoing the very first day that we had. So let's see. We are on day 6, which is significantly longer than I thought we were going to spend on this. But hey, that's how it goes. Then it's just a matter of testing out a whole bunch of lenses again, like we did on the first day of the Geometrical Optics, and going from there. So if we finish early, and if I cannot figure out what I want to do with this simulation, yeah, it's probably something closer to this. But let's see, you probably can't see that one. I don't know. Anyway, so what I want to do then? What I want to do is get started with it, work on it, finish everything up, and then after everything is done, I might take one day off. And that one day off will be me trying to prepare whatever we're doing next. Again, I'm kind of split between doing just implementing an FFT from scratch and also doing conformal mapping or doing conformal mapping. I don't know which one's easier because I actually don't understand either one at this point. So I'm pretty sure, I mean, everyone's done an FFT before, right? So, except for me apparently. So I need to code that one up. That'll be fun. And then, what else do we need to do? The conformal mapping thing, I think, is just a matrix transformation on a plane of points, but I'm not really sure how to do it. So we'll see, because I feel like there's more to it than that, right? The idea behind conformal mapping is that we take a 2D object and we stretch it around a 3D one. So we take like a 2D texture and we wrap it around a 3D, I don't know, ball or something like that. So I'm not sure. There's probably a lot to it, and I'm not sure exactly where that is, so I'm kind of looking that up. Again, if we go into mapping, we're probably going to do 2D to 3D, which is conformal mapping, 3D to 2D, which is just projecting back. Hey, Gustorn, thanks for coming in. Then we have a couple of other things. I want to try to do some 4D stuff, which means we have to project 4D to 3D. Lots of things to do. I'm not really sure the best way to get it all done. But we'll see what we need to do from there. Good. Okay. That's all we need to do for an intro. We made significant project progress last time, and again, we are almost done with this. We will be done with it pretty soon. So let's go ahead and cd into the appropriate directory and do what we need to do. Project Simuleos, and of course, Geometrical Optics. cd project Simuleos and Geometrical Optics. Good. Now let me see what we've got. We have right now, let me ls, what am I going to do? Let's do Mirage, frames, animation.gif. Let me see what we actually have up. I've got a feeling, yeah, so we have a very old animation up. This is definitely not what we currently have for the simulation. 1 second, I'm kind of fixing my sleeves. For some reason, last night I had a good idea to roll out my sleeves that I typically wear for this shirt. Great, except it's super hot in Okinawa right now. So that might not have been the smartest idea. Hey Ginfiro, thanks for coming in. How have you been, man? Okay, so of course this isn't quite what we have now. So let's go ahead and let's take a look at those images. Hey Alexandra. Okay, so 1 second. Good, done is done. Now what are we gonna do? Let's go over here. And let's finish up that texture. So we're going to do the Geometrical Optics. Actually, I think it's Optics Visualization.cpp. CPP. There is the security guard. Always goes by around this time. Lots of waves. Okay, so we have a couple functions. One that we wrote yesterday, which was index plot, and another one we started to write yesterday, which was create index. What I'm going to do is create index texture, just so I know what we're doing. And in here, instead of index rect, let's change these all to index texture. Because I think index texture kind of makes a little bit more sense here. So let me go to rect. And let's do texture. Next. Okay. Now, if I remember correctly, we pretty much finished up this function. Oh, there's one more I missed. Here we are. Texture. Okay, we pretty much finished up the function yesterday, so let's go through and check to make sure. We have int vector size is the radius times the radius. Seems good to me. We say vector double is going to be index texture. Good. Index texture dot reserve vector size. Seems fine. Double r prime vector location. All right, those are both good. We go through I, we go through j. These are going to be our x and y axes. We find a new r prime, which is going to be the radius at that particular point. And then we just find the refractive index at every point. Yeah, seems good to me. Okay, so now let's go down here and let's modify index plot. What I'm going to do is at the very start of index plot, let me see, what are we going to do? We need to, yes, so we need an index plot function that reads in just that texture. So I'm probably going to leave this function in, and then what I'm going to do is the following. So we're going to say Function, let's say overloaded. Function, to fill, wow, that wasn't right. Fill inside of lens with appropriate index of refraction. Colors. Good. Now, one thing that I failed to read in, or one thing I know we need to read in, is that lens color. Let me see. What else do we need to read in? I think just the vector of, yeah, I think just the vector of, how do I put this? The index texture. Okay, so let's do it. Void index plot. What do we need to read in? We need to read in frame, ampersand animation. Then we need to read in vector of double, so std, vector double. And we want, 1 second, what did I call it? Index plot. Oh, that's not what I called it. Index texture. Okay, what else do we need? We need color, lens color. And of course, outside of that, we also need the max alpha, which is basically the maximum we're going to allow our object to be non-lucent. What's it called? The opposite of translucent is opaque. The most opaque we're going to allow our object to be. So now we're going to say double max alpha. Anything else we need? I don't think so. Shoot, we're also going to need the lens, aren't we? Constant sear lens. Yeah, we're going to need that lens because the object that we're working with is just a square, right? So we need to figure out where to put it on our overall system. Okay, so we have this. Let's go down to the end here and... Oh, by the way, guys, I've been using this text editor for years. Just now found out about replace mode instead of insert mode. That's, that would have been useful to know a long time ago. I found out about it a few days ago. You should really pre-multiply the text here with max alpha. Yeah, I intended to. Oh yeah, there's one thing that I forgot to do here. Let me go here. Normalizing. Let me see. Index texture. Okay. And let me see. And I guess we could do the pre-multiplication stuff too. No, we can't. No, we can't. Yeah. The reason we cannot is because the alpha changes with time, right? So it starts out at a particular value. So let's say it starts at 0, and then goes from there. So let me see. We'll find a way to do that. Okay. So now we have to normalize the index texture, which is definitely something I think we need to do, right? Let me think. What else do we need to do? If we normalize the index texture, yeah, it definitely needs to be normalized. Definitely needs to be normalized. Okay, so we're already going through all the points here. Let me just very quickly, since we are going through all the points, and I'm not sure. Yeah, since we are going through all the points, I'm just going to do this. Let's go here and let's find max index of refraction. Let's go here. We have double here. So we're going to say max index. Good. And let's go down here and say, maybe we can set this equal to 0. And then we go in here and we say, here, if, let's say index texture of this guy right here is greater than max index. One second. You shouldn't need the lens radius inside of the texture indexing. Not sure why wouldn't we exactly? Let me see. I less than lens.radius. 1 second. index with I and j. If you want to work with the same bounding box, then just index with I and j. I'm not sure I fully understand. So, we need the lens radius here, and actually it's not the lens radius, it's 2 times the lens radius. Thanks for catching that. 2 times the lens radius. But, let me see. If you work with the same bounding box, then just index with I and j. Oh, you're talking about in here. Oh, I see. Let me see. We are using the same bounding box. Let me think. Yeah, I'm not sure. Okay, so let's go here. And let's do if index texture, then we say max index is going to be equal to index texture here. Okay, so how would you propose, what would the index look like? It is 1D, Zadison is right. I could have made it 2D, I suppose, and that would have saved some effort here. But how do you propose the index to look like if we don't have the radius in there? There's Cairo image surface create for data. Holy cow. That's the longest function call. Cairo image surface create for data. Yeah, so I guess we could create a surface and put the surface at the appropriate location. Let me see. I'm not sure exactly what this does, so let's take a look at this. Let's go over here. Open up a new tab. And let me see. You're just going to be iterating with the same number of pixels. You'll need zero-based indices in the per frame function as well. Let me do example. I guess that is an example. Okay. You'll just need zero-based indices in the per frame as well. Then you can reuse the surface with different alpha blending, I guess. I'm on mobile, so it's kind of hard to explain in detail. That's fine. Sorry about that, Gustorn. So, what am I looking for? I'm looking for Cairo. This guy. So, next one is going to be down here. Data, format, width, height. Stride. Okay. Let me see. Do you have an example of this guy? Data, format, width, height. Is there another one? Is that the same one? Oh yeah, it is. Oh man, I'm super tired. Okay. Creates an image surface for the provided pixel data. The output buffer must be kept around the Cairo surface T and its droid, or Cairo surface finish is called to the surface. The initial contents of the data will be used as the initial image contents. You must explicitly clear the buffer using, for example, Cairo rectangle or Cairo fill if you want it cleared. Okay. Note that the stride may be larger than the width times bytes per pixel, and provide a proper alignment for each pixel in row. This alignment is required to allow high performance rendering with Cairo. The correct way to obtain a legal stride value is to call Cairo format stride for width with the desired format. All I want is an example now. So let's go back. Let's see, Cairo for bitmaps. Maybe you want something. Alright, well, all I wanted was an example, right? If that's an example, it's super long. Let me see. Bitmaps. Let me see. What else do we have here? Image surface. Hey, Zivo. Thanks for coming back, man. Not much. How have you been? So let me see. Cairo image surface create for data.txt. Maybe this explains something. No, it doesn't. Dagnabbit. Okay. I'm gonna take a little bit longer looking for this, and then I might just call it and just create our own function for it. Let me see. Cairo format stride for width. What am I looking for again? Control F. Yeah, that one. Enter. Pixels. Good. Cairo format arg. Okay, that seems fine. Width, height, row, stride. Okay, so I don't know what row stride is. Is it an integer? I think that was defined previously, and I think it was an integer. Maybe this is good. Done a lot of traveling, come back with some fresh ideas for projects, but starting tomorrow, I'm too lazy at the moment. I totally understand that. When I get back from a trip, I can't do anything. You can use the exact same for loops in your preframe function as your texture creation function. Let me see. Use the exact same for loops in your preframe function as your texture creation function. Let me see. Animate line. What am I looking for? I'm looking for the function that calls, it should be draw lens or something like that. Animate circle, draw lens, here it is. Okay, so we're going through all the frames. Now let me see. Lens.radius. I'm not sure. Let me think. So we're reading through, we have an individual, wait, let me think. We have a, wait, I'm thinking here. We're going through all the time steps, right? Each frame is a different time step. And then what we're gonna do is, let me see, create index texture. Here, let me go ahead and normalize this. So we did something really weird to get the max texture, max index. That seems fine. Now all we have to do is normalize everything in index plot, I think. Index plot. So you're saying down here. Let me see. Yeah, so we are going through everything. Let me think. I think we still indexed it correctly up above. I think that's still right. Because I mean, we're going to be going through this loop in the very same way, right? I don't know. I think it's right, but we'll see. Okay. Yeah, I see these two for loops, and the two for loops start at vertex X. Not quite. So the difference is that this one starts at vertex X, and this one starts at I equals 0. And this one starts at vertex Y, and this one starts at J equals 0, right? And so we need the same number of points, which is going to be 2 times radius this way and 2 times radius this way, but they're not quite the same, right? One has an obvious starting location, the other one does not. I think. We'll see. And so what you're saying is, let me see. On mobile, hard to explain. Wait, you can just iterate over the same number of pixels. See zero-based index for the per frame function as well. Okay. Oh, I see what you're saying. So what you're saying is, up here, we give it vertex X and vertex Y here, and then down here, we don't have to worry about it. Okay. Yeah, they are the same with the translation, right? 1 second, gonna get a sip of water. But I'm not sure, I'm not quite sure what, oh, never mind, we'll take it. Okay. Yeah, I'm not really sure what needs to be fixed though. So now we have to normalize the index texture. Let's go ahead and do that down here. So we're going to say basically the same thing we had before. So basically these for loops without stuff in the middle. So we can just grab those for loops, remove some spaces. Sorry about that, Gastorn. Let's go here, remove all the interior stuff. And now what we're going to say is index texture of this guy right here. Yeah, I guess I need to think about it some more. Again, it always ends up being that later on I figure out what it means. So let's just kind of give it some seconds to kind of give me some time to think about it. Okay, so this should then normalize everything. Good, so now we have the appropriate index texture. Everything should be set. Let's write this. Over here, let me just make it real quick, just to make sure it does make. Max alpha was not defined in the scope. You probably move the index expression out into a temporary. You should probably move that index expression. Oh, I mean, maybe. 1 second, let me find max alpha was not declared in the scope. That's because it's not alpha, it is index. Okay, so then you're saying, I mean, either way, we're gonna have to calculate every loop here, right? So that's not gonna speed anything up there. But it should speed something up here, I guess, because we'd have to calculate it 3 times. So let's go here and let's say double, where's my ints? I don't have an int. Oh, yes, I do up here. So then let's do temp. Yeah. Let me say, see, we're using index of refraction, and we also need a new index count. So it's kind of like, the names are kind of annoying. So I'm just going to call it K. And let's go down here and let's do K is going to equal this guy right here. And then we put in a semicolon. And then we go down here and we set this to K. This to K. And this is K. Oh, oops, I just deleted more than I needed to. If index texture of K is greater than max index. My bad. You can also remove the if in the loop and add f max in the line above. Yeah, I could just use maximization thing for the... In fact, maybe it would be better, I think, to find the max or something like that in the... let me think. There's probably a better way to find the max. In fact, there is an inbuilt function probably to find the maximum search for max or something like that with C++. That's fine. I can implement that later. Let's go here and make. Okay, so it seems to make just fine. That vector is full of uninitialized values and it's indexing out of bounds. Wait, what? That vector is full of uninitialized values and it's indexing out of bounds. Max index is equal to f max, max index, index texture. 1 second. That vector is full of uninitialized values and it's indexing out of bounds. That vector is full of uninitialized values. Why would it be full of uninitialized values? So we say if r prime is less than length.radius. Oh, I see what you're saying. Yep. We need an else statement here. So let's go here and let's do else. We will say, let me see. Index texture of k is going to be equal to 0. That's fine. We're going to pass the size into the constructor. Yeah, I just didn't remember how to do that one. So, I mean, what's the difference between... I mean, I guess we could... So how do we do that? Do we do that this way? Vector size. Is that right? I don't remember. Make. Okay. That is not... Okay. It's not a big deal there. I feel like Gust1's seeing something that I'm not seeing. So let me see. We have 4int_j. You said the index was out of bounds, but I don't think the index is out of bounds. I think it's going through exactly what we want it to go through. We have I equals 0, I less than 2 times radius, I plus plus. That's how far I want it to go. So that seems fine. Index texture of vector size. So up here it should be 4. Vector size. Wait, what is this? Oh, I see. 4 times. Okay, so now let's see. That should do it. Yeah. Good. Okay, so now what else do we need? I think then that should be fine. Good. So let me go down here, and let's go ahead and put recreate the index plot function. Shouldn't be so bad. So we're gonna do the following. You're indexing at 4 times r squared plus 2r. You don't have enough space for r squared? Wait, what? Let me see. R squared is here. Vector size is lens.radius times lens.radius. That's fine. It should be... Let me think. We have lens radius times lens radius is going to be r squared. It should be 2r. Yeah, it should be... Isn't it? Where's the plus 2r coming from? Wait, why is there a plus j? Let me think. Why would there be... max I is 2r minus 1 though. Let me think. We should have... That's just because of zero-based indexing, right? So... Let me think. 2r minus 1 times 2r plus 2r minus 1. 1 second. You're right, Gustron. There is an additional element we have to take into account. Okay, so let me think here. Well, this should be right. Right? I mean, that's the number of points that we want. That's definitely the number of points we want. Else branch handles pixels outside of the circle, but inside of the square. Yeah. We go here. And really quickly, in circle. And then here we say out circle. Outside of circle. I think it should still use K. Yeah, I think K should be fine. Because K is a general... Yeah, I think K is fine. Okay, so let me see. For I equals 0, I less than 2 times lens.radius, I plus plus. So I guess because it starts with 1 based indexing, we probably need to add, a minus 1 here. So because C++ starts with 0 based indexing, and I was naturally counting in 1 based indexing, so let's go here. Oops, not what I wanted to do. Minus 1. Minus 1. So I guess maybe that should fix it. We'll see what happens. What that happens is we run into a situation that we need to fix. Okay, so honestly, this isn't going to change that much. Now, we have that function that Zadison brought up, which is Cairo image surface create for data. Oh, yeah, you're right. You're totally right. Yeah, I don't know what I was thinking there. Okay, so let's go down here. So, again, we have that Cairo image surface create for data. I don't really know how to use that. So what I'm going to do now is I'm going to do a very simple scheme without that, and then we can use it later and see if maybe that fixes anything. Honestly, this function isn't going to be that much different than the function we had above. So let's just go ahead and grab this function above and modify it. Here. Pop down here, and put it in. Okay, so creating the square that we'll be working with sounds fine to me. We have the vertex. We can remove these spaces and go from 0 to 2r minus 1, not 2r. Yeah, that's exactly what we want. Okay, so now we have r prime, index of refraction. Sounds good. We're going through all the vertices. Also good, we have an x and y location. Good. R prime distance. What happened, Gustorin? if I'm doing something wrong, let me know. I will do my best to fix it. I'm just trying to, sometimes I can't fully grasp everything people say in chat. So let's do r prime less than radius. And let's say index of refraction is the refraction at. Now, in this case, we don't want this. We want the following. We want index texture. Not a problem. Don't worry about it. So we'll say index texture. And then we have to read in the appropriate index for index texture. That's okay. So this is going to be... Yeah, you're right. Thanks for catching that. Otherwise, we'd be completely screwed at this point. Well, not completely screwed. We'd figure it out, I'm sure, but it would have taken some time. And based on how bad I was at debugging yesterday, holy cow, it would have been just like, I don't know what's happening. Like, I would have just been completely frazzled. Okay, so index texture, what do we need to read in here? We need to read in I times 2 times radius plus j. And I think that should be the appropriate index. Our rectangle, everything else should be the same, actually, now that I think about it. At least so far as I'm aware. Okay, so let's go ahead and try to implement this in the lens function that we have up here. So we have, let's see, create index texture. Not the one that we want draw lens. Here. Okay, so the first thing we want to do then is to create index texture guy. So what do we have? Animate circle. Good, so let's go ahead and create the, this guy. So we're going to say do std vector of double, and we're going to call it index texture again. And this is going to be equal to create index texture of the following. So we want lens is all we need to read in. We'll see what happens. Then we go down here and we do index plot, but in this case, instead of reading in what we were reading in before, we read in these guys. Oops, 1 second. These guys here. So it's frame animation, std vector double, index texture, lens, lens color, and max alpha. I think most of it's the same. So we go into animation, index texture, lens, lens color, max alpha. So, oh, do we also need frame number? Let me think. Shoot, we also need frame number. So let's go here and let's do int frame number. Good. You know, using the std vector here seems a little unnecessary. You could use unique pointer double, but then again, std make unique is C++14. Yeah, actually, I'd never heard of a unique pointer before. Now, that said, probably used all the time, but I'd never heard of it before. So that's why I chose the vectors. Vectors are just simple for me to understand. Okay, so I think these are then the same calls as we had before. It's just we have an additional index texture after frame number. So let me go up here and let's add that in. So where's index plot? Here it is right here. So I is frame number. Now we do index texture. And again, we do the same thing down here. I index texture. Good. Now, what else do we need? A smart pointer type that automatically deallocates storage for when you when it goes out of scope. Okay. So that's something I need to look into then. But again, I'm always hesitant to do things on stream that I've never done before. Like, it takes some time for me to learn it. If it is, you've never heard of it before because most tutorials teach old C98 standards. Yeah, but honestly, C++14, if that's what we're going with, is still relatively new, you know? So, like, when I learned C++, it was a very long time ago. That said, I then forgot it, and then I relearned it. So, you know, in my relearning period, I really should have, you know, fixed it then, or learned some new standards then. But at the same time, I was learning it for numerical physics, which is still using Fortran 77. So, you know, it's kind of hit and miss. So let me go ahead and open up the, what do I want? Optics visualization.h. And let's go down here and add this function call. So index plot there. And let's add another one here for the new index plot. And then we also need to do one for the create index texture, which I think I'll put under draw lens right here. So where's that? Index plot. Here it is, create index texture. And yeah, we don't need the node anymore. Okay, let's see what we got. So let's grab this, put it over here. Oops, my bad. Now we have it over there. Ooh, and a semicolon. Did I put a semicolon down here? I did not. Semicolon. Right, quit. STD unique pointer is C++11. Make unique, which is the exception safe way constructing a unique pointer, is C++14. Okay, fair enough. Again, I always kind of have to plead ignorance on some of the most up-to-date C++ stuff. In fact, I kind of find myself not wanting to use C++11 just because it's there's a lot of features in there that are super nice, but then a lot of features that are super hard to read and understand for new programmers. And I find it, I don't know, at least for me, also as someone who does not know of these features, you know, I find it a lot of times almost unnecessary, just because, again, I'm coming from an area where this kind of stuff is not typically seen in code. That said, people are getting better, but it's still, I mean, people are still using Fortran quite regularly. Okay, so what do we have here? 371 is what I'm looking for, 371. And I think this is because, yes, am I not reading in a radius? It should be lens.radius. But that's weird. I would have thought that we would have lens color. Let's change this to lens color here. And let's also change the other guy up here. So let me optic visualization.h. Let's do lens color. I know you're found. Lens color. Are you kidding me? So index plot, where are we here? Lens color. Oh, it was an underscore. Of course it was an underscore. I don't know what I was thinking there. Right, quit. Now let's make that. Give it a second to make, and now it's running. So we're gonna see what happens when it pops out images on the other side. This could be really good, it could be really bad. I have no idea what's happening, so we'll see what's up there. Vid is 13. At least C++11 is kind of standard. Yeah, it is standard, you're right. Oh wow, that took significantly less time than I was expecting. Let me actually time it. So let me do time, geometrical, and let's see how long it takes. We could convert it into an animation, that's fine, but not necessary right now. But yeah, C++11 is I would say the standard C++ at this point. C++14 is what I would say is kind of at the cusp, like this is where people are really trying to improve their game. And C98 or C whatever, like old C school stuff is what people are currently using on supercomputers and stuff. So only 15 seconds, that's significantly faster. Now let's do Mirage temp, where we're putting all the images. Image 000 whatever.png. Scroll down, here we have the lens being created, and nothing happens. That would totally explain why everything's set. That wasn't even okay. So what are we gonna do? I did something wrong here. Let's see, index plot. IOR is equal to the refractive index at, and we're gonna multiply by max alpha. Now, let me try something else really quickly. So let me try the following. Let me go to geometrical.cpp, and let me go down and change the refractive index to something that's trivial. Let's just do a super trivial index, similar to what we did before. So let's see, else index is equal to 1.0, and what I want to do is up here. Where does that else statement start? Yep, this is what I want. So let's grab here, comment this guy out, and let's just set the index equals 1.4. Oh, sorry, that was an L, not a semicolon. My bad. Now let's go here and let's make that one, and let's see what happens. Now I've got a feeling that we're doing something weird with the texture, so I'm gonna have to do a quick or a certain amount of figuring out what it is that we've broken. But that's okay, you know. So let's go into Mirage Temp, scroll down a little bit. Yeah, okay, so it's not fading in. Making it can still throw, I imagine, some sort of errors. So let's go here, optics visualization.cpp, and let's see. So everything ran without a problem, right? So let's go through and check to make sure that we are going in all the functions that we need. Vector create index, index plot, What I want is draw. Yes, that's what I want. So we have animation, index texture, lens, lens color. So let's go through the index texture and let's check to make sure we are getting the appropriate index of refraction. So where are we? Create index texture right here. All of the all of the indices of refraction, I suppose, should be 1.4. So we should have a max index of 1.4. So let's go here and let's do std cout max index and line. And let me just very quickly write something in here saying max index is, and there we go. Snapper cactus. Oh, so what's happening? I've been watching for the past 10 minutes, but still confused. Okay, so the way the stream typically works is I stream for 2 hours every day from 5 to 7 o'clock a.m. Japanese Standard Time. And for the first 10 to 15 minutes, I described the problem. So unfortunately, you came after that. All we're doing right here is some simple geometrical optics. The idea is that we're doing ray tracing through a lens where the refractive index modifies or is modified on the interior of the lens, right? So we have some sort of function of R, and then we can see the light actually bending. It's simple refraction, but with complicated refractive indices. And that's kind of what we're working on. The Mad Dave, it's working over here. Sorry. Good luck. Okay. Is the HTML5 beta? So for me, I thought the HTML5 beta was already up like a very long time ago, like a few months ago. But maybe it's not. Maybe I was incorrect about that. I thought when they changed their video player to do that weird like, fade in from black thing at the bottom, I thought that's when they changed to HTML5, but I'm not sure. Okay, so let's go down. We're gonna write out the max index here. What else do we want to write out? Let's also, when we're doing the index plot down here, and I realize there's gonna be a lot of data to output, but I want to see what happens if we output it here. Yeah, so let's see what happens if we output it here. So let's do std cout, and we're gonna say index of refraction is index of refraction and line. This is gonna be a heck of a lot of data, but that's okay. So let's do go into the makefile. Let's go down here and good. So now let's make it. Okay, this is gonna be a lot of data. That's okay. The index of refraction is always 0 apparently, and I just broke it. Fantastic. So that would be the issue. The index of refraction is apparently always 0. Let's go here. But I apparently misunderstood how make unique works. Yes. I don't know, because you know way more about it than I know. Okay, so let's keep working on it. The index of refraction apparently is always 0. So that if r prime, oh my gosh, of course, I'm an idiot here. 1 second. We have I, we have j. I don't know what I was thinking here. We have location I, we have location j. We don't actually need the location here. These are our indices. So let's go here, dd. We don't need r prime. We don't need any of this. We can get rid of all that. Okay, let's remove a couple of spaces here. So let's see, 4x should be about right. There we go. Now, we already have our i's, we have our j's. So now we just have to go to the appropriate index texture. Now, the thing is, this is not exactly obvious. So we have a vertex x and a vertex y where we're starting. Okay, we have the chiral rectangle. And so we do actually need the location x and location y. I apologize. I was kind of going on a rampage there, deleting things I didn't need to delete. That was my bad. We do need the location x and location y. Equals I. And then we do location. Oh my gosh, what am I doing with my life? 1 second, add a space there, go down to the end. Then we do location y. Dot y is going to be equal to j. Now, here's the thing, guys. I'm going to mix up these indices up here. So instead of starting at vertex.x, we're going to start at 0. And we're going to start at 0. And then down here, we're going to say vertex.x plus I. And vertex.y plus j. Good. Okay, so now we have the index texture. here. And we should be going through all the I's and J's, no problem, right? Now, since we have the indexing correct. Now, we need to put it into the appropriate place, which again isn't so bad. We just put it into the location of X and Y over there. So I think, if I'm not mistaken, I think they should be set. So let's go here, write this, go over here. Let's try making it one more time. Of course, location is not defined because that's my bad, guys. Totally take the blame on that one. Shoulda had it in there somehow. Location. There we go. Let's write this, go over here, make it one more time. And, we're getting random refractive indices. That's good. 0.714 is not what I was expecting. Oh, we get a bunch of ones too. Wait, why do we get ones? Wait. This is not quite right. So let's go ahead and Control C. Let's go down here. Let's comment this out. Write this, go over here to make. And let's see, when we originally make the texture, max index is 1.4, as it should be, because we set the entire index of refraction on the inside of the circle to be 1.4. That should be okay. Give it 20 seconds to run. I think it takes about 15 seconds to run. But it seems to be taking longer this time, which might be good. Who knows? Okay, so now let's go into the images one more time. Mirage temp, scroll down. Okay. That's something. 7.4 is 1 divided by 1.4. This is not quite what I was expecting. Okay, so I expected the index of refraction on the inside of the circle to be just one smooth lens. I don't know what's happening here. And I'm not quite sure what's happening up here. Yeah, I'm not positive. Yeah, that's not right. But look at that fade in. Come on, guys, that fade in is beautiful. Look at that. It's not the right index of refraction, but it does fade in appropriately. That's good. Okay, so let's go ahead and close that guy. And let's see if we can figure this out. The image approach might make things simpler and easier to debug. Maybe, I just don't know how to do it. So let me see. We have each of the individual locations. Okay, so let's go ahead and try that make surface. The problem is, drawing a surface onto another image is a pain in the butt with Cairo. It's not the easiest thing to do. And because of the way I have everything done, I don't know how to do that step. So we could create a surface. Let me think, we've done this before. Writing multiple surfaces to the same image. Oh, I could put it on a new layer, I bet. Yeah, I could totally put it on a new layer. I could put it on the layer up top. Let me think, how did I do those layers? So I could put it on the layer up top, and then it wouldn't be hard at all, I don't think. Let's finish this one up, so that we have something that's working. And then we'll try to do the other one. Because again, it's... Let me see how I did the layers. So let me go here, to the very top. And let me check this out. So let's go to Optics, Visualization.h. Struct Vector, seems fine. Let me go down to Main. Well, don't know what happened there. Main. What? Oh. Geometrical.cvp. Main. Okay. So, in the layers, we basically have... let me see, a whole bunch of frames. And the frames are pulled together with draw frames. So let's go and look at, or draw layers, right down here. That's where we do the drawing of the layers. So let's take a look at that. So let's go down to draw layers, and we read in that. Of course, it's not there. So let's go into Optics Visualization.cpp, and let's go into draw layers. Okay. So we have the layers here, and we have the PNG ID. The number seems fine. Okay, so what are we doing? We go through, could you do the lens drawing code one more time? Yep, I will go ahead and go down here. Refractive index at, wrong one. VI index, oh, not what I I wanted. Optics visualization.cpp. Go down to the bottom. And it's this guy right here. Okay. So I'll be looking over here real quick at the draw layers command. It looks to me like all we do is we say png base plus number plus dot png seems fine, and then we do Cairo right to png frame surface. Good. So every layer has its own surface, and png c string. So yeah, we could just write it to the layer on top, and then we'd be set, I guess. Okay. But let's take a look at that image again that we had just a second ago. So let's do the last mirage, and let's scroll down. Okay, so the question is, why was this happening to begin with? And that's not something I can really answer right now. So, you need to subtract vertex X and vertex Y from I and J for the texture indexing. Let me see. Oh, wait. Fourier I equals vertex X plus, yeah, 1 second. You're totally right. So let's go here. Let's write this. Right, quit. Go over here, close this, and let's make it real quick. Make. Give it a second to do it. Do the making. It should take like 20 seconds, actually. So again, I apologize. I always say 1 second, but I mean 20. We're in, programmer time, so that kind of makes sense. Everything takes 7 times as long. Last mirage. Oops. Scroll down and okay. Okay, well that fixed one of the problems, but we still have that other one in the top corner. Open it up again. Let's see, so we're going from 0 to lens dot radius times 2 in both I and J. Okay. Location X is going to be vertex X plus I. Location Y is vertex Y plus J. Those 0.707s are kind of bothering me. Or 714. I know it's 1 divided by 1.4, that's fine. But we shouldn't have an index of... Oh, no, we should. Because the index of refraction on the outside of the circle is always going to be 1. Okay. Okay, that's interesting. So... let me think. That means we're clipping. We're hitting the outside of the circle when we shouldn't be. Not that that's a horribly big deal, it's okay. Okay. So vertex X is equal to the upper left-hand corner. Vertex is equal to the upper left-hand corner. That should be okay. We do index texture of I times 2 times lens dot radius. Is that right? Let me go up here really quick. Where do we define a lens texture? Create index texture, and we set, yeah, k is equal to I times 2 times lens dot radius. I put an int in front of lens dot radius, but I don't think that's really going to fix anything. Okay, what's next? Cairo rectangle. Again, the problem would have to be in the locations that we're working on here. So location vertex X plus I, vertex Y plus J. I'm not really seeing a problem here. Let me think. So why would we be doubling up on those points? We know for a fact that the max value is 1.4. So the max index is 1.4. Okay. This could be going wrong in a number of places. It could be that the texture that we're reading in is not right. And that's something that we need to kind of address no matter how we do the visualization. So let's take a look, or let's think about how we would check that texture. Let's go up here. Index plot. Create index texture. Seems fine. This is probably where we're going to run in. I say seems fine, but this is probably where I would think that we'd run into issues. So with the normalization, that seems okay. Divided by max index. Max index is 1.4. Aren't some of the y coordinates negative? No, the way Cairo counts, it counts from 0 to 1000 or whatever it is down here. So, wait, why would they be... 1 second, let me think. G? Lens.radius? Vertex? It should be that they're all positive. King Gartru 007. Don't you want to use a better editor, like Notepad++? No, it's fine. I'm fine with one of the most used text editors in existence. Okay, so the issue then would be this random this random corner up there in the corner. Redundancies. This random quarter circle up there in the corner is what we need to get rid of in this visualization. This guy shouldn't be here. It should just be one smooth lens. Nothing going on the inside. Okay. So, let's see. Vertex X plus I, vertex Y plus J. Okay. Cut rectangle. Location X, location Y, 1, 1. We already fixed that from last time. Should be okay. Cairo set source RGB. No homo. Well, thanks. It is a standard American axis, so far as I'm aware. I don't think there's anything different about it. Okay, so let's go here. Vec vertex, vertex.x, vertex.y. Again, guys, if you guys can see the obvious problem here, let me know. What I'm going to do... okay, if we can't figure it out in a couple minutes, I'll go ahead and commit... this version to GitHub. But I think we might be able to figure it out. So let's take a look at the texture again. Gustorn agrees it's probably somewhere in the texture, so if Gustorn agrees, we're set. Gustorn knows everything. Well, most things. Usually when it comes to something like that. You want to show both of them? That's fine. So let's go into optics visualization.cpp. Go down to the bottom. So here are the two functions that we're working with. Index plot and create index texture. Okay, I'm going to be looking over here on this terminal. Create index texture constant sphere lens. We are reading in the appropriate vector size. Should be okay. Double index texture vector size. R prime max index equals 0. Location. Do we even use location? Yes, we do. I plus lens.origin.x minus lens.radius. Yes, that should be right, because that's where the vertex is. Okay, so now what else do we do? Square root of I times I plus j times j. K equals I times 2. Huh. Lens.radius plus j. Man, if the problem is with the texture, right? How would we check the texture? What can we do to check the texture? We can go through and we can just plot out all the points, but that's not exactly ideal, right? So what if we're within the circle? No, I don't see how it could possibly be with the texture. The texture says the max index is 1.4, right? So if the max index is 1.4, this should be all you need. Cairo image surface create data for unsigned character. No need for loops. Cairo set source surface. Set source RGBA. Cairo paint. I can't paint it right now. But yeah, this is what I was saying. I could draw this on another layer. That inside the circle calculation is so weird. This one right here. If R prime. Let me think. Why is it weird? Refractive index at... Wait, why is this one weird? That inside the circle calculation is so weird. I'm not seeing it. If R prime is less than lens.radius. Oh, are you talking about how we check to see if we're inside the circle? I mean, it seems really standard, doesn't it? Oh, wait a minute. Let me think here. No, this should be good, because we're going from 0 to lens.radius. That should be okay. The index texture needs to be changed to vector unsigned character. Wait. How do we change it into a vector of unsigned character? Like, what do we do to do that? Because we have doubles, right? So if we have doubles, okay. I admit that the code from Cairo is probably a little bit easier to work with, right? However, I don't know how to do it. So I guess I'd need some hand holding there. I just multiply the double as 255 and cast it. Okay. Maybe that's not so bad. Okay, so how about we try that then? Because it seems a little bit easier to work with. So we want frame animation, int frame number. We also are reading in... Ah, crap, this is now super complicated. Okay, so now in order to do this... Ah, man, that's incredibly complicated. Okay, so let me think. We have 3 layers. Oh, maybe we can do the Cairo paint thing. Maybe we can. Yeah, maybe you're right. Maybe we can. Let's try that. Okay, so let's see. Now what we're going to do is after normalization, let's also multiply by... let me think. So instead of vector double, you said we want vector of unsigned character, right? Unsigned character. Okay, let's go down here, and we're going to say vector double of index texture, which we're going to need. But we also need another vector, std, vector of unsigned characters. And what do we want from here? We want index texture. What do we want? Index texture. I guess we'll call it char of vector size. Okay, let's add in a semicolon. Remove this reserve statement. Good, so now we have all the vector doubles, and now we just need to cast it into the appropriate vector. So now, appropriate, oh, we can probably do that up here in this loop, can't we? So we have index texture here. Now what we need to do is the same thing. So let's go up here and define k, which is going to be equal to exactly what we had before, here. Put it down there, and change this to k here. Okay. Now, we have everything set. Also, this may not help much, but it's faster to do I times I plus j times j, less than lens.radius equals... Okay, sure. It's not a big deal to me, so I can go ahead and change that right now. Lens.radius times lens.radius. Okay. Let's go down here now, and we're going to say index texture, let's see if I can type right, character of k is going to be equal to index texture of k times 255. And my guess is that this should be okay. I think we're automatically casting, right? Because, well, we'll see. Now we want to return index texture of character. Let's go down here to the bottom. And what do I want to do from here? I want to comment out these loops for now. And I want to pull in Zadiston's code. So let's go here real quick. We don't need vector location anymore either. And let me think. So let me take a look at this code. Why not just index texture character equals unsigned character, index texture divided by max index? I could do that too. That would work also. So let me go ahead and grab this, and let's read it in. So I'm going to comment this out. We have vertex X and vertex Y. I think I'm going to keep those. Let's paste them. And then let's do some work on that. I'll go up here. We can fix this. It's fine. I'll leave it as it is because I might need some of that in a bit. So we want index texture.data. Let me see. How would I want to do this? I guess something like this maybe. Good. Drop this down over here. Okay. So what do we have here? We have unsigned character, index data, 2 times lens.radius, 2 times lens.radius. Seems good to me. And then we give it the location to start with. Wait, no we don't. Set source surface. Oh, we give it here. is where we want it. So vertex X and vertex Y. X and vertex.y. Good. We're gonna have to drop this down to the next line. And we're gonna add some spaces here. We're gonna have to do this for all the lines, so good. Let's see what happens if we just run this. I've got a feeling it's just gonna break. But that's okay. We'll see what happens. Oh, it's actually working. Wow, that's quite nice. Give it a second to run, and if this works, it works, and I'm happy. Now, I don't know how long it will take to run. Somehow I've got the feeling that it'll take longer than the other one. So let me time that. Maybe it'll be the same amount of time. Who knows? Technical Freak 808. Yay, magic. That's like programming, math, and science, like, all together. Actually, when I was like 7 or so, I used to think that mathematicians were math magicians. You know, I thought they were like, you know, that's what they were actually called. Okay, so this tells us that the error is definitely in the texture creation. Good. Good. In the end, this took just about the same amount of time as doing it the other way. So we're gonna leave the other way commented in, and we're gonna take a look at the texture creation now. Okay, so create index texture. Again, the issue here is that we are randomly creating an additional quarter circle up here, and I don't know why. So we have to figure out where that quarter circle is coming from, and how to get rid of it. But first, I'm gonna get a quick sip of water, and then we'll go from there. Any sufficiently advanced technology is indistinguishable from magic. I mean, I guess that's true, right? I mean, I've always kind of wondered, like Harry Potter, for example. They've got a whole wizarding world, right? And they have all these, like, cool magical things. And for us, the whole magical thing, it's super cool because we're like, oh, this is really cool. I'll definitely take a look into that. But like, I'm wondering why it is that the magicians are never wowed, like, when they go into the real world, because, like, we can do, like real world, you know what I mean? Like, it's crazy, the stuff we can do with technology. It's absolutely insane. Anyway, what was I gonna say? Technical Freak, how old were you when you started to learn, programming? The first time I learned to program, I was like 14 or 15. Maybe say I was young, entering high school or something like that. However, I then completely forgot everything about it, and I basically relearned it when I entered college. So that was 6 years ago, something like that. Let me see. Circle containment is wrong. You're going from 0 to 2R, but sorry about that. Checking if the circle it was at 0, 0. Okay, let's see. So we have k is I times 2 times int lens.radius plus j. So what you're saying is we're going from 0 to 2R, but checking as if the circle was at 0, 0. Yeah, that would definitely be a problem. So let me see. Index texture. Let me go over here. Oh, that wasn't what I wanted. I want to go over here and fix something real quick. That kind of has been bugging me, but isn't a big deal. Good. Okay, so location x is equal to I times lens.origin x minus lens.radius. Okay, that should bring us over here. So here's the origin, here's here. Okay, then we say, do something like vector position ij, auto dist, equals distance lens center, position, if dist is less than lens.radius. Okay, so let me see. So we're saying auto distance is equal to distance lens dot center. I think. Oh, wait a minute. Let me see here. Location X, location Y. It's gonna be IJ. Yeah, we can totally do that. In fact, is that not what we did? I don't know. Let's fix this. So we have location X is equal to this, and I think the location X and Y should be okay. And that's going to be Gusterman's vector position that he has right there. Now we need to say distance So let me go here. I think distance is a double. So let's say distance here. And we're going to say distance is going to be equal to, I think, didn't you call it like length or something? Let's do this, ls, and go into optics visualization. Oh, I think geometric. Dot h. Inline plus minus distance. Let me see. Distance. Here. Oh, okay, so we already have the distance. It's going to be the length of a minus b, should be fine. It's going to be distance of... 1 second. Lens dot origin and location. And now we go down here and we say if... Actually, this should be our R prime, shouldn't it? That's okay. Let's get rid of the R prime. And let's go down here and say if disk is less than lens.radius. Oh my gosh, what am I doing? 1 second. Write this, go over here, right quit. That's way more efficient. Let me see. So I minus lens.radius, location y is j minus lens.radius. If location x times location y plus location y times location y less than radius times... the plus in the location code should be minuses. Let me think here. Is that not exactly what we had before? I'm pretty sure that's what we had before. So we said location x times location y. But you're saying I times lens minus radius. This should do the same thing. Let's do this. Let's make it. I think. Error. Create index texture. Radius was not declared in this scope. 2 times radius. 1 second. Didn't we just make it a second ago? And didn't this just work a second ago? Oh, holy crap. You know what I probably... Okay, what do we do here? New declaration. Let me see. Note old declaration. You can do dot loc less than r times r. 1 second, we got an error. Let's fix this error and then we'll get back to this. Okay. Cannot convert double to Cairo T. 1 second. Let's go down to 367. Okay, so 2 times lens.radius here, which means actually, guys, when we ran this last time, it didn't seem to work. I'm not sure exactly how it worked last time. I must have forgotten to write or something, and I apologize for that. So can I convert double to Cairo T? Let's go to 370. Here. Lens color, source, RGBA. Oh, that's because we need the frame number first. So we want animation.frame context. Frame number. Oh, no underscore. Now we want to bring the green and blue down to the bottom. Let's see if that fixes the bottom 2 errors. Let's make that. Okay, so now it says ambiguating, which I hope is a word. New declaration of std vector unsigned character. Create index. Oh, I know the problem. Let's go into optics visualization.h. And let me go down to create index texture. And we're going to change this to unsigned character. 1 second. Right quit. Now let's make that. Create index texture lens. Conversion from std unsigned to vector is requested. Okay, fair enough. So let's go to 231. Okay. We want to change this to unsigned character. Make that. Okay, so we got a whole bunch of errors here. Let me see. We have no matching function for our index plot. Of course, we have to change index plot too. So let's go down there and let's do that. So let's find the bottom here. Down to index plot. We're finding these one at a time, but we'll get there eventually. So this needs to be changed to an unsigned character. unsigned character. We'll pop it down to the next line just to keep everything set. Right, this go over here to index optics visualization.h. And for index plot, we have to do the same thing here. So unsigned integer. Good, and we're going to pop it down to the next line like we did before. Okay, we'll right and quit that. Let's make this. Okay. What are the issues now? No mention call for index plot. Animation I index texture. Oh, what did I do? Unsigned character, not int. Did I do something wrong? Let me go down here. Oh, thanks. I wasn't... I was doing it kind of quickly. Okay, that fixed it. Give it a second to do its thing. And this would explain why it took the exact same amount of time. So let's check the time for this. /geometrical. And this should be significant. I think it's gonna be like 10 seconds. Let me see. 7 seconds. That's pretty good. That's half the time. Okay, so now let's take a look at this image. And I swear, if this image is working, I'm gonna be kind of sad. Let's go to Mirage. Okay, good. So everything's broken. Okay, so this is something we now need to think about. And I'm not sure exactly how to fix this one. Actually, you know what's bizarre about this? The center circle turns white. Like, look, it's blue, and now it's white. It was blue, now it's white. Okay, so let's see if we can figure this one out. So, cover image surface, create for data. Index texture.data. Okay. So I'm assuming that, yep, we're creating it blends.radius. Okay. Format stride for width. 2 times lens.radius. Cover source, set source surface. Okay. Giving it the appropriate location to start at. Giving it the appropriate alpha value. Wait a minute. Lens color red. And then we do frame context, frame number. This doesn't seem... Okay, let me do something else then. Let's go down here. We have vertex X and vertex Y. Let's comment this out again. And let me just make sure that this is still broken. This other one down here. So, let's make that. Oh, oops. Control C. Make this one. Give it a second to do this thing. Optics visualization.cpp. 1 second. Lens color. But we used color set source RGB before. 1 second. Let's do Mirage temp. Okay, so this one is almost kind of working now. Hey, the Mad Dave. Glad you finally got it working. The problem is it all comes in at once. And I'm not exactly sure how to fix that one. We wanted it to fade in, but it's, you know, getting there. Okay, so the texture I would say is probably fixed then. Right? I would imagine so. But now for some reason it's not fading in. Wait a minute. Lens color max alpha. Why on earth would it not be fading in? Man, one mystery after another. But hopefully by the end of the day we will have at least this finished. And then we can do the ray tracing again tomorrow. I, again, apologize for taking so long with this, but I don't know, it's been fun. I enjoy it. Even if you guys maybe don't, I enjoyed a good bit. It's super fun. Okay. So vertex.x. No. The problem is in the alpha. Mirage temp. Okay. You have to divide by 250. Oh, crap, you're right. You're totally right. Let's go down here. Set source RGBA. So what I want to do then is index texture. And we're going to divide this by 255. Operate this, go to make, and let me just see, just to make sure this is working, and then we'll kind of go back and forth. And then we'll see if we can get the, because the Cairo Surface T is much faster. So in the end, we probably want to use that because it's twice as fast. Sorry about that. 255.0. Let's see what happens. We're already like 20 seconds. Okay, so let's go here. Mirage image. Hey, it worked. It's fine. It worked. That's exactly what we want to see. That is perfect. Absolutely beautiful. The texture is fixed. Now we just have to get the other surface thing to be fixed. And then we can start visualizing some crazy refractive indices. Yeah. Okay, so let's go down here. And let's comment this out. Okay. So let's see if we can figure this guy out then. Let's see. So up here we do Cairo rectangle, Cairo set source RGBA. Let's see, Cairo set source surface. Okay, then we do Cairo fill. Hey, Vitus13, what's up? Actually, were you here earlier? Yeah, you were. Why did I say what's up? You were here for the past 20 minutes, 40 minutes, at least. Anyway, my apologies. Okay, let me think. Vec vertex.x, lens origin.x, minus lens.radius. None of that should be the problem. The problem is in this section right here. Cairo surface T image, and then drawing this to the surface. So let's see what happens if we don't set the RGBA. Because Edison mentioned that this could be part of the issue. So add in some comments there and some comments there. Write this and let's make it. Give it a second to do the thing. PogJump refractive indices. We're actually getting there, right? So let's do Mirage Temp. Okay. So what this did is it turned the circle from blue to white. Okay, so that's something we have to figure out. I'm not sure why the circle's turning from blue to white. No idea there. Okay, so let's see, what else can we do? So if we leave this in, oh, you're actually using Live Streamer. Wow. So that's the thing. I think, who is it? I think Gustorn uses Live Streamer, and I'm pretty sure Krams uses Live Streamer too. It's what a lot of people do. It's quite nice. And IRSSI, in my opinion, is perfect for what I need it for. That said, other people probably want other things, and that's fine if they want to use other things. So Mirage Temp. Dang it. Why does it turn the circle to white? That's the thing that's really just getting at me. Why would... We already drew all the circles, didn't we? Yeah, we totally did. We drew all the circles already. So, if we do not do this at all, if we don't run this section of the code. Let's write this, go over here. Let's make that. We don't run that section of the code. We get a blue circle at all times, I bet. Yeah, so let's go into Mirage. The circle is, oh no, it changes to white too. Holy crap, why does it change to white? Why does it change to white? That's bizarre. Well, I'm here to get my head into this, but I'm always terrible at math, so my head is starting to hurt from thinking. That's fine, that's how it is when you start programming, right? It probably overlays a new layer, and so the circle outline saturates at white. That's weird. Okay, let me make sure this is written, and let's try it again. Because I commented this section out, so it should not be an issue. At least I don't think it should be. Okay, so let's take a look at this. Mirage Temp, blue circle. Why? It's not blue when we do this. It is blue when we do this. Let's make it. I think you need to put another Cairo paint before Cairo set source RGBA, as well as Cairo set operator. Okay, yeah, we can take a look at that. Okay. Just take Algodo. No need to program. It goes white when you start adding the lines. Yes, it does. However, the lines are on... Wait, let me think. Maybe you're right. Maybe... Let me check this. So the thing is, when we go here, we draw a blue circle, and the circle stays blue, right? But why does it stay blue if other cases it turns to white? Well, the thing is, I've been programming for a while, but when you do desktop applications, you don't usually use much math unless you do games. Oh, maybe that's true. Yeah, I guess... Yeah, I believe that, maybe. Sure. Yeah, I believe that. Okay. So let's go ahead and... Man, that looks great. That's exactly what I want to see. Okay, so let's see if we can figure this out. So Zadiston said we should change some stuff. So let's go here. And let's see. Oh, why am I doing the wrong type of comment all of a sudden? Okay. So what Zadiston said is what we need is a Cairo paint before the Cairo set source surface RGB. I run numerical code. So much math. Yeah. Trust me, I know exactly what you mean, Blackberry T. You do math so you can resolve problems in pure procedures. Actually, Marion, what... I'm not sure... I'm actually not sure what we mean by math. If that makes sense. Like, I don't know. Anyway, it's fine, it's fine. Keep talking. I'll figure it out. I can't do much math either when coding, but it really depends on what you're building. Also make index plot the very first call for each frame. The very first call for each frame. Okay, so let's go ahead and fix a couple of things here. So the first thing we need to do is Cairo paint before the Cairo set source RGBA. So let's do that. So we're gonna do Cairo paint. Okay, so you want to do Cairo paint. We want to do 2 Cairo paints? Okay, well, let's just see what happens. Cairo paint, animation, dot frame context, 1 second, context, frame number. Okay. And then you also said we want to do, if you resume math is a set of operations, so if you resume the set of operations to a formula, you have done it the easy way for the CPU. Yeah, I suppose so. Okay, and then you also want Cairo set operator context, Cairo operator dest atop. Where do I want to put that one? Let's see. I guess set operator. What if I just put it up here? So we want Cairo set operator. I think that's spelled right. Good. Animation dot frame context of frame number. And then we want, what's next? That's fine. I'm just about to put it in there, so I'll just copy this, put it over here, and let's see what happens if we make this. It's making, that's good. It has to be after the first Cairo paint. Okay, I'll put it in after that. So this one's probably gonna break then. But that's okay. Broken code is not a problem here. In fact, you could argue broken code is the only thing we work on here. So let's go ahead and write this, go over here, quit this one, and let's try it one more time. That one seemed to be taking a good bit of time to run, but maybe it was just my imagination. So we'll give it some time to do its thing. You need to reset the operator after too. Oh, this is getting super complicated. Okay. So what you're saying is we want to reset the operator twice. So we go there and we also go here. It does seem longer though, doesn't it? Black Theory T. Operator over. To have... Okay, let me see. Operator over is the default. What? Yeah. we need to think some more about how to get this to work with the Cairo stuff. There's definitely something going wrong right now. Yeah, I'm not sure what's happening underneath. Actually, let me run top real quick. Yeah, okay, that's fine. Let's go ahead and close this. Now, let me Control-C out of here. What we currently have is code that is working for the other refractive index. It is currently working. Even though we don't have the Cairo stuff working right now. So let me go ahead and let me see, how do we want to do this? If we don't have this operator in here, I bet you it'd run just fine. So let's go ahead and make it. Give it a second. Maybe not. The first line isn't... One second. The first line that isn't going through the lens is mildly infuriating. Yeah, we can remove that. The thing about it, though, and I'll show you why I like having it there in just a second. So let me take a look at this image. Mirage Temp. Yeah, it's doing the same thing as before, and I'm not sure how to fix that. So here's what I'm going to do. Let me go ahead and show you why I want that in there. Real quick. TGB, DD here, and DD here. Let me go ahead and right quit and go into another file we have, which is geometrical.cbp, down to the bottom. And we have this lens in here. This is to show a light is slowed down by the matter. Yeah, exactly that, Marion. So what I want to do is I want to comment this guy out. Oh, I wanted 2 of those. Not knowing C++ code is kind of a pain. Let's go here, and let's go down here and comment this like so. Okay, so this is the formula for the invisible lens. If you look this way, to me, you'll see the invisible lens, and I'll explain why it's invisible in a second. So let's go ahead and right quit. Let's see what happens. We're gonna make it, and it's broken. Okay, so let's fix it. Difference R, geometrical. Of course that's an issue. Oh my gosh. That's what I wanted. Right, over here, make. Okay, this one seems to be making just fine. Max index is 44,080. Wrong comment? 1 second. Give it a second to draw. It's going to take probably... Actually, I don't know how long it's going to take. Oh, that wasn't so bad. Okay, so let's go ahead and take a look at the images. Move this over here. So here we're drawing our lens. And then... Okay. I know what's wrong here and why we only have a single dot. Not sure how to fix this one, but we'll think about it. Okay, so we have light kind of going through here. And if you look at that top line, you can see it just barely skirting over the top of the edge. That's how fast light should be moving. However, here's light. Light just hit the end there, right? So this is frame 109. It takes until frame 264. So, well, okay, let's say 250. So it takes almost 70 more frames for it to get to the end. That's significant. We've significantly slowed down light with this refractive index, or with this lens, and that's pretty cool in my opinion. I don't know about yours, but I find this really cool. So let's go here. Let me go up to the top. Okay, no. Wrong file. Let me go into optics visualization.cpp and let me try something. What I want to do is not normalize it this time. I just want to see what we get. So here's index plot. Where's our index texture? Here it is. And I'm just going to say this. Comment this guy out. Right. And let's go to make. Give it a second to do its thing. It's going to take some time. I'm trying to think of the best way to visualize this because it ends up being that the refractive index at the very center of the lens is incredibly high. Which means that the refractive index everywhere else is not going to be visualized if we appropriately normalize it. Returns doubles if you're not normalizing. So, yeah. If we're not normalizing, this will not work. Wait, why not? Oh, you're right, that didn't work. That's broken. Why is that broken? That's super weird. Okay, well, Gustorn was right. This doesn't work. Oh, shoot. I know why it doesn't work. You're totally right. Yeah, because we're not normalizing. So here's what we're going to say. We will say if index texture. Let's do this. Divide equals 2. Yeah, but it's not physical. So let's do max index. Let's leave this as it is. Index. And let's go down here and let's say index texture of k. Divide equals, just by some arbitrary number, 2.0. Now we're going to say if index texture of k is greater than 1, we're just going to set it equal to 1. So let's do here. Oh, I thought it... index texture of k equals 1. 1 second. Make... The problem is that... Yeah, but I thought... Yeah, you're right. We should be using doubles here. Yeah, it seemed like they did wrap. I mean, that kind of made sense, right? And maybe there's a way... Okay, so... Okay, give this a second to run, and then we'll take a look at this. So let's do Mirage Temp. Scroll down. Okay, so we can kind of see what I wanted to see in here. Let's divide by 10 or something. Instead of by 2. 1 second, so let's divide by 10. And let's make that. Just another sake of visual, can you make the middle line another color? We probably could, yeah, definitely could. Let me see. Give it a second to run. And then we'll look into all that. It should take about 20 seconds, I think, for the visualization to occur. Doubles also make normalizing unnecessary. Yeah, that's also true. Good, so let's run this. Mirage Temp. Okay, that's okay. We can kind of see what's happening here. We have a very high refractive index in the center and kind of a low refractive index everywhere else. So, let me think. So the reason we're having unsigned characters is so that if we do the stuff with the Cairo, so let me go down here to index plot, down here. So if we do, what happened there? Did I break something? No, I don't think I broke anything. Okay, anyway, Cairo surface T, image. So if we wanted to do this, although I can see the matter takes away energy from the light, I can't tell the path of it. Let me see. How about using reinterpret cast then, if it's truncated to a byte? We could. But again, I'm not sold on the unsigned character yet. So let me think. We can actually very easily cast it into the unsigned character. However, I would like... You know, I'm not going to say that this doesn't work yet, right? Because the adding in the surface thing almost worked. It's just not quite. Although I can see the matter takes away energy from the light, I can't tell the path of it. Let me see. Mirage Temp. Oh, 1 second. Zoom over here. And also let me resize this window so it's the appropriate size. Scroll down a little bit. Okay. Although I can see the matter takes away energy from the light, I can't tell the path of it. What do you mean the path of what? Are you talking about the path of the light? As in you cannot tell where the light's going to go, based off of the index of refraction. Is that what you're saying? Not sure if I totally understood the comment. Okay, so index plot. Again, so this is the reason why of the middle one. Oh, of the very center. Freaking, I don't know what that was. That was either a hair or a bug. You're talking about of this middle guy right here. Yeah. So what's happening with the middle guy, I mean, obviously it's a little bit different. A Although I can see the matter takes away energy from the light. Oh. Yeah, so actually, it is slowing down, right? I mean, you have a changing refractive index, right? So it's definitely slowing down. In fact, the reason it's not the same length as all of the other guys here, it is actually still losing energy in a way. It is slowing down. The lens is causing it to slow down. It should be the same length as all of the other guys and the outside of the lens right here. Yeah, you're right. It's not so bad. So I'm gonna do that. I'm gonna change all the unsigned characters back into doubles. We're just gonna do that. I'm not gonna worry about it right now. But Marion, the issue here is that the light is being slowed down, right, by the lens itself, and it should be at the same length as all of these guys, but it's not, because we kind of arbitrarily truncated it at the center, because otherwise we have a oh shoot, what do you call it? A singularity at the center that we have to account for, and I don't want to. And so we just kind of arbitrarily cut it off. Well, not arbitrarily, like we knew why we were cutting it off that way, but we cut it off at the center so that we don't see the pure refractive index there. So if we did see the actual invisible lens, then we wouldn't see this extra line here. Like, this would be the same length as all of the other ones that went through the lens. I hope that made sense. Feel free to ask questions if that doesn't make sense. Using Cairo instead, need 1 second, vector, unsigned character. We could just improperly calculate the limit at the center. It's not infinity. Oh, neek. Yeah, we'll take a look at that. Good. So let's go ahead and fix all these guys into doubles. So I should just be able to unsigned character. All right, you ready? Let's break something. So I'm gonna do this. S unsigned character, and we're gonna say double. G. Okay. Right and quit. We're gonna go into optics visualization .h. We're gonna do the same thing. Unsigned character, double G. Oh, dang it. Do we not have any? Unsigned. We totally do. I misspelled that. Let's try it again. Actually, let's do it again. Let's do it this way. Unsigned character, double G. Dang it. Yes, we will in just a second. S. Come on. Unsigned character, double G. There we go. Right quit. VI optics visualization .cpp. Down to the bottom, let's look for 255. There's one. We don't need this anymore. And I need to put a quick note up here. Thanks, Fitus. Note. Yeah. Simple 255 factor. Different. Okay, so let me go up to the last 255 up here. There. There. Okay, so let's go to start, comment this guy out. And we're going to return index texture instead of index texture character. Leaving another note here. Note, return index texture character if using Cairo. Okay, so now we have this. We don't have to arbitrarily do this. Now what else? Seems good to me. Remove the whole normalization. we could remove the whole normalization. However, I would like something that we can multiply. Like, I would like to have a function in here that allows us to multiply by some factor. Actually remove the whole section. I get this section has less speed, but the same distance as the top. It'll look better without normalization. It will look better for this visualization, but I've got a feeling I want to keep it in for now. I've got a feeling that some of these lenses might actually look better with the max index. I would just like to leave it in there for now. Chiral mask surface. Okay, I'll look into that maybe tomorrow or something. Okay, so let me go here. And let me add that in here. So we're saying chiral mask surface. Thanks, Addison, for doing that. Okay. We've divided by 10 in this case. What I want to do is divide by 5 instead of 10. So let me see. Index texture here. So let's do this. Times 5. Or 5. And in fact, let's do it this way. Instead of dividing by 5, let's multiply by 0.2. 0.2. Right, that? Okay, let's see if it makes. 1 second. Make. It seems to be running, so we'll see what happens. Just delete the first paint and replace Cairo source image with Cairo mask surface. Okay. Cairo mask surface. Source image. 1 second. Where are we? Cairo source surface with Cairo mask surface. So we want, yeah, Cairo mask surface. Okay, we'll try that in just a second. Write that, and then let's go to Mirage. And okay, there we go. This one looks pretty good. I like that. Looks great. Okay, let me just try one more lens pattern real quick, just to make sure that works. 1 second, right quit. Let's go into geometrical.cbp, down to the bottom here. Okay, now, delete the paint. 1 second, we'll do that in a second. Hey, Duck of Doom, what's up? Okay, so what I want to do now is I want to comment this guy out over here. So we're no longer going to be using the invisible lens. And let's use another guy. So let's see, we have this here. Index is equal to f absolute value of index. I don't actually remember what this guy looks like, but let's just take a look. Why not? What's the worst that could happen? Right quit. Actually, that's fine. I just wrote. That's okay. Make this 249. Here we are. Index. Expected a. I think this is the Batman one, right? So let me see. Function absolute value of r greater than cutoff. What am I missing? I'm missing a. It's saying I'm missing a squiggly, but I can't find the squiggly. Let me see. If absolute value, let me see. Else. Oh. Obviously. I don't know what I was thinking there. Thanks, Addison. And then I just... Let's write this, go over here. Make. Give it a second to do its thing. And then we'll take a look at the refractive index. See here, the max index is 30,452. No, yes, 30,000. Holy cow. So we'll have to look at this one once it's done. We might have to do some arbitrary factors and see what we need to do here. So let's go ahead and right quit. Optics visualization.cpp. Now what I want to do is up in the, what am I doing? Index plot. Let's take a look at what this looks like. Mirage image. Okay, so here we have our system here. And this is not the Batman function. This is something else. Oh, I see. It just gets higher and higher as we go towards the center. Yeah, that's pretty cool, but it's not quite what I was expecting. Let me go over here to our geometrical function, and let's see what we have. My question, index is equal to f absolute value of index. Oh, I just redefined it. Why did I do that? Let's go here. Rate this, go over here, and let's make that. And then we're going to, max index is 2. That's perfectly fine. In fact, we're going to have to change this one. So let's go ahead and right quit. Objects visualization.cpp. Let's go down here and let's modify our system. Okay, that's not right either. They're all just being reflected. Something's going wrong here, and I'm not sure exactly what's wrong. Oh no, they are being reflected. They're not going into the circle. That's different. Okay. I know for a fact this was working. Anisimico, so I might be a bit stupid here, but what's so special about this GIF that we need so much math to calculate it? So what we're doing here is we are calculating, and honestly, we're not using that much math. So I'm a little bit worried here, but anyway, that's fine. The idea here is that we're basically just watching a ray of light going through a system with varying refractive index on the inside of the lens. And so the idea is that the light is kind of moving around, and we're modifying the function on the inside of the circle, and we're going from there. So let's go ahead and right quit. And yeah, I'm gonna have to look into this one. I'm not sure exactly what's wrong. If f absolute value is greater than cutoff. Wait, what's our cutoff here? 0.01, that's fine. Okay, let's just go ahead and comment this out for now. Dot. Else index is equal to 1. So it's like ray tracing? Yeah, it is ray tracing, yeah. Okay, so let me think. There was a really cool one. I think it was the error function. Let's do that one. So let's do index is equal to the error function of r. And we'll just set this index equal to 2 or something like that. I don't know. Rate this, go over here. Give it a second to do its thing. Not quite at the stage where I can program it yet. Definitely want to learn about it. I suggest the MIT video about pack of light into a soda bottle. Oh, I think I've seen that one. Yeah, it's pretty cool. Give it a second. Max index is obviously 2. You should be amazed. Okay. 1 second. Still running. Okay, now we're gonna run Mirage. See what it looks like. Oh, that doesn't look right. That's nothing. Absolutely nothing. Let's do error function of r. Why is this not doing what it should be doing? Make. Let me think. Yeah, I'll take a look at it in a second. In fact, why not? Let's do it now, because all of these are. So let me go to github.com. And let me see here. I want to go to Simuleos. Issues. A few refractive index functions. It was error function of 1 over difference. But the difference should be my r. Let me take a look here. Mirage image. No, that's all 1. Let's try 1 over r. For some reason, it's not doing this. 1 over r. Give it a second. And make 3D. Yeah. Yeah, so this obviously didn't work. I don't know what's wrong with it. If absolute value of r is greater than distance. This one didn't work either. Well, it kind of worked. But that's not what it's supposed to look like at all. Yeah, that's wrong. Okay. Well, at least we have reflection happening. But that is totally wrong. Okay. Let's just try 1 over r or something. Write this, go over here to make. And let's see what happens. Max index is, of course, infinity. That's because I'm an idiot, but that's okay. Well, let's see what the light does. Oh man, I don't understand. What is broken? Mirage temp? What on earth? Why is this broken? Let's just take one of these guys. 1 over square root of difference. I know this works. It has worked before. So let's change this index to be, let's say 100 or something. And let's say 1 over square root of r. Make. Alright, I'm doing something wrong here. Okay, so if absolute value greater than cutoff, all of that stuff's commented out, so none of that matters. Besides, I can just copy it again later, so I might just do that. Okay. This is actually kind of frustrating, a little bit, because I know we had all these really cool visualizations, and now none of them are appearing. So let's do Mirage temp, and they're all just reflecting now. What is happening? So here's what I'm going to do. I'm just going to remove these guys for now. Let's go ahead and get rid of them. And let's see, index is 1 over square root of r. I didn't actually do anything different. Index equals 1.4. You should have the same value 1 over r inside and outside the circle. No, I totally wrote. Let's do make one more time. You actually didn't copy the function properly again, but that's obviously not the problem here. Yeah, index equals 1 over square root of difference. Yeah, should be okay. Index equals 100 should be fine. We just arbitrarily cut it off, but that's fine. Mirage temp. Yeah, why are they reflecting? This is completely different than what we expected to get. Okay. Well, that's a mystery. Let me see. If f of absolute value is greater than cutoff, if inside of lens, and f of r greater than absolute, yep, that should be fine. Else r equals cutoff. Let me see. R equals cutoff. Nope, that should be okay. Let me see. Wrong path. What do you mean, am I in the correct file? Let me see. Right quit. ls. Let's try this. Let me do GNU plot geometrical.gp minus. Range is invalid. VI geometrical.dat. Wait, do we not have a geometrical.dat? Oh yeah, we modified how we're drawing this. Yeah. That's totally fine. Let me go into geometrical.cpp one more time. Go down here. Let me see. F absolute value. We should still be writing to file though, shouldn't we? Propagate. Let's see. Here we're outputting to file. Let's do that. Let's make this. Error array p. Output was not declared in the scope. Let me see. Do we have that? I think I modified this too greatly. Yeah, I don't think we have output anymore. Dang, that's unfortunate. So let's go ahead, comment this back out. It's weird because the invisible lens is totally working the way I want it to work. At least I'm pretty sure it is. We just showed the invisible lens, right? So it should be working. For some reason though, nothing else is working. So that's a bit disconcerting, but let's see what happens if we do this. Let's comment this out. Just as a sanity check, let's make sure the invisible lens is still working. DD here, and DD there. Write this, go over here, make that, and let's see what happens. And after this, guys, it's 7:05 in the morning, so I'm going to go ahead and end the stream here for the day. It's a bit annoying that we're not getting the appropriate plots, because I know earlier we totally got some incredibly cool basically rays being traced through the lens. But for some reason, it's just not happening. So that's something we need to kind of look into. And I guess we'll go from there. So tomorrow we'll try to fix this problem. And hopefully we will be able to... Yeah, that one works just fine. Dang. Hopefully we'll be able to fix it up tomorrow, and we can go from there. What I'm going to do now, guys, is I'm going to go ahead and right quit. We're going to quit quick get status. And, ooh, my bad. Let me clear that so no one sees any of that. Get status. Dot. And let me go ahead and add in everything that we need. So we're going to do the following. We're going to do git add makefile, which has been changed to geometrical.cpp. Geometrical.gp has been changed, so I might as well add that one in too. Geometrical.gp. Geometrical.h. And then optics visualization star. And I think we don't need makefile Cairo, geometrical. Everything else should be good to add in. Let's see, H, optics visualization, good. So now let's run another. Okay, fine. .h and optics visualization.cpp. Now let's do another git status real quick just to make sure I didn't miss anything. It looks like, yeah, the only things that we don't have are those, so let's go ahead and do git commit. Adding Cairo visualization of invisible lens. Other lenses to come, exclamation mark, right and quit, git push origin master. And you guys now should have access to this on github.com. Give it a second to run in. Good. Okay, so this is found. Here's my channel. Scroll down. Wait 1 second. Info. Scroll down. Click on the GitHub link either here or here. Let's click on that one. Go to Simuleos, and it will be available in... sorry, I misspelled invisible. My bad. Geometrical Optics, and I did misspell invisible. Don't pay that any mind. Geometrical Optics here, and this is the file that we are working with. As long as you have Cairo installed, you should just type in the make command, and it should make the appropriate images in your temp directory. Okay guys, that's about it. Thanks so much for watching. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we hopefully figure out what the heck is wrong with the current visualization scheme and why the visualization of the different refractive indices do not seem to be working anymore. And then we'll continue working on the different visualizations from there. Again, today's Thursday morning my time. I think we'll be done either tomorrow or the next day. Then we'll take a day off. And I will then get started on the next simulation after that. I haven't also misspelled as of... Oh, did I? My bad. I'm sorry. I totally did. Adding Cairo visualization for invisible lens. I was rushing. My bad. Anyway, guys, I will see you tomorrow. Have a great day. And yeah, that's about it. Thanks again for watching. Bye, guys.